This is question number 74 in chapter 6. It says, you and your bicycle have a combined mass of 80 kilograms. When you reach the base of a bridge, you are traveling along the road at 5 meters per second. At the top of the bridge, you have climbed a vertical distance of 5.2 meters and slowed to 1.5 meters per second. Ignore work done by friction and any inefficiency in your bike or legs. Question A. What is the total work done on you and your bicycle when you go from the base to the top of the bridge? And we'll start there. So this is kind of your picture. You're going along and you climb up to the top, and we're going to find out what kind of work the bridge does on you. Yeah. So we'll start with work equals change in kinetic energy. Or work equals delta K, which equals K2 minus K1. We can change that to 1/2 mass times velocity squared. Mass times velocity squared. K2, so that's our final, minus 1/2 mass times velocity squared initial. We can then change that to 1/2 mass times velocity final squared minus velocity initial squared. We then have all the values that we need. So your mass is 80 kilograms. 80 times your 1.5 squared minus, it was 5, 5 squared. When you plug that in, you get negative 910 joules. So that's the work done to get you up the hill. Now question B is, how much work have you done with the force you apply to the pedals? So for this, we can use the same equation, work equals your delta K, but then we are going to add your mass times gravity times that height that you change. So it would be K2 minus K1 plus mgh. Because we've already worked out that equation, we can just take our mgh and add it down to this equation here. So plus 80 times 9.8 times 5.2. Let me make sure I got the numbers right. I did. So when, I haven't put this one in my calculator yet. When you get all of that, you get 3,166.8. joules. And that is question 74 in chapter 6.